Good morning, good afternoon. Welcome to everyone. You're in the presentation for Low Oxygen Brewing. My name is John Watt, and I'm the founder and CEO of Stout Tanks and Kettles. I'm honored to be joined today by Brian Rabe. Hi, Brian. He has led the low oxygen brewing movement. He's done a whole lot of studies and experiments and created a lot of data and information that's been extremely helpful to understanding low oxygen brewing and making better beer like the Germans make their continental style lagers. He's responsible for the lowoxygenbrewing.com website. And honestly, I've learned most of what I know about low oxygen brewing from Brian and his co-conspirator, Derek Scott. I'm going to be giving the bulk of the presentation, and then Brian is going to be available to answer your tough questions, and I know you're going to have some, and other questions as well. As we go along, please use the chat feature. You can ask questions there, and then we'll handle them at the end of the talk. And also at the end of the presentation, we're going to have handout notes that you can download and keep that will give you a lot of the information that I might talk about that might not be shown on the screen. So don't worry too much about taking notes as we go because you will get the pertinent data from those handout slides when we're all done. Okay, so we're going to jump into the presentation now. I am going to turn off my camera so your screen gets a little bit bigger. Low oxygen brewing. And what beers are often missing that the low oxygen brewing processes can provide is the fresh, lingering grain flavor. And as you probably know, when you drink a authentic German or continental style lager, you get that amazing grain flavor in the beer that's hard to come by otherwise. Here's a personal fresh craft brew seeking lingering fresh grain flavor for good times and fun. So what is lingering fresh grain flavor, and what does it have to do with low oxygen brewing? Well, it's that wonderful grain flavor, as I just mentioned, that you get in those authentic continental, typically German lagers. And low oxygen brewing is a way to get it into your beer. So I'm going to ask a question you can't answer, but have you tried to get that fresh lingering grain flavor into your beers? Have you tried to replicate those German style lagers? I'll bet you've tried decoction if you have. Have you tried using melanoidan malt? Have you tried flaked barley? Well, if you've been trying the decoction mashes, melanoidan, flaked barley, and similar methods, you're probably wasting your time trying to replicate the continental lagers. You probably have not achieved it. You'd be kind of like these two people in this picture. If you're older, you might recognize the cultural reference to smoking cigarettes and watching Captain Kangaroo. You might as well be just doing that. But I hope that by the time we're done today, you're going to feel confident that you can also get the fresh lingering grain flavor in your brewery, in your beers. So, what is low oxygen brewing? It's not this animal. And it's not just eliminating the hot side aeration from your boil kettle. It's going after the sources of dissolved oxygen and eliminating or reducing them from each step of your brewing process. It covers steps you didn't know you needed to worry about because the fact is it just takes 1 part per million of dissolved oxygen in your brewing process and you've lost that fresh lingering grain flavor. So our mantra for today is this: if you can't hit 1, then you're done. If you can't hit 1, then you're done. 1 part per million. So why bother with low ox? Well, I've been alluding to that already. The main reason for most people is to make those authentic continental style lagers. But there's more. But basically, it's keeping the amazing in your beer because it's going to preserve the fresh malt flavor that already exists in the malt. You're going to obtain the lingering fresh grain flavor, and you're also going to improve the overall quality, flavor, freshness, shelf life, hop character, even in ales. Think about those hazy IPAs, improving that. So now we're going to jump a little bit into, here's why. I forgot that slide there. Okay. So here's some of the science behind it. This is a diagram of ascorbic acid oxidase. We'll just call it AAO. It's one of many malt antioxidants that, when preserved, again, I say preserved, you're going to provide the glorious, fresh tasting, lingering flavor in your beer, grain flavor. This is the amazing that we're all trying to achieve. But because AAO and its cousins are antioxidants, any part of the hot side brewing process, if any part contains oxygen, then the oxidase is consumed and expelled, and that flavor is lost. When you dough in a typical mash tun, you smell it, that wonderful grain aroma. What is that? That's the evaporation of the AAO and the other antioxidants. You can smell the loss of the fresh lingering grain flavor as you brew. So when you do low oxygen brewing, on the hot side, there's practically zero odor. You're preserving the flavor and the aroma into the beer until you serve it. Frankly, when you first brew with low oxygen brewing methods, it's pretty strange when you don't smell that amazing smell coming out of your mash tun. But that's a good thing. You're preserving the flavor in your beer. So dissolved oxygen, DO, that's your enemy. DO is what oxidizes the AAO and its friends, and that's what removes the amazing fresh lingering grain flavor from your beer. Why? Well, if the dissolved oxygen, this is empirical work that Brian Rabe has done, but if the dissolved oxygen is more than 1 part per million throughout the entire hot side process, the fresh malt flavors are gone even before you begin to boil. Ideally, you want to get down to less than 0.5. Actually, it's close to 0. And if you have the right equipment, close to 0 is very possible. Again, if you can't hit 1, then you're done. Okay, so the targets, again, hot side, less than 1 part per million. Packaging, you want to be less than 0.15 part per million. Well, let's talk about the sources of dissolved oxygen and kind of see what we're up against to get that out of our process. There we go, hot liquor, 8 to 12 parts per million. Dough in, 1 to 3. Splashing, like when you mash in, and can't put a number there because it just depends on how much you splash, frankly. The atmosphere, 1 to 2 parts per million per hour. So just sitting there, doing nothing, your wort is absorbing oxygen and expelling the AAO. Copper, brass, and aluminum. And then also our source of dissolved oxygen and loose hose connections, especially on your pumps. So by keeping dissolved oxygen down, you're going to preserve the lingering fresh grain flavor. And here are the sources we have to go after. These numbers look pretty big. If you're trying to get less than 1, you can see there's a pretty big potential number to overcome, but it's really not that hard. There are some pretty simple techniques that can get some of these numbers down to 0 or near 0 very easily. Again, if you can't hit 1, then you're done. So there's some prerequisites we're going to talk about first in terms of your equipment and your capabilities. So if you want to make the German lagers, you need to be able to step mash. To get the hot liquor, you need the dissolved oxygen out of hot liquor. There's a couple ways. One of them involves boiling the water. So you would need to be able to rapidly cool your hot liquor tank down to your strike temperature. Or you can treat your hot liquor tank with yeast and water. There's 2 ways. We'll talk more about these as we go. When you're done brewing, you need to rapidly chill your wort down to lager temps. You don't have a lot of time to do that because you need to get the fermentation started. You need to pitch at a rate that's going to get the fermentation started off quickly. So that means for a lager, 2.5 million cells per mil per degree Plato. Temperature control on your fermenters. Most breweries, it looks like we have mostly commercial breweries here. There's a number in the smaller size, but fermenter temperature control is really important in the German lagers. Commercial breweries tend to have it. Some of the smaller breweries may not. Be able to keg, pH measurement and control, having a small scale, and eliminating copper, brass, and aluminum from your equipment. That's why we had the big red circle over these copper, beautiful looking copper kettles. Just as a quick note, there's brazed or copper heat exchangers. Those can be a problem as well. So you want to look at that. Here's some helpful features on your equipment for low oxygen brewing. So first of all, if they can be sealable to keep the air out, that's really helpful. Having gas inlets, part of the process is you can purge the tank with nitrogen or carbon dioxide would be your typical gases to get the air out, get the oxygen out. One on the bottom of the kettle for pre-purging. Up on the upper top could be for purging while you're using the kettle. As a quick note, if you want to put a check valve on those gas inlets to keep the liquid out of the gas line, make cleanup easier. Having a gas outlet on top for venting, so as you're pumping gas in, you need to let it out. Having a pressure relief on the tank for safety, like less than or equal to 5 psi, depends on your tank. Also, the vacuum relief there will protect you when you're draining the tank if you have it sealed up and you forget to keep the gas pressure on and let air into the tank, which is, you don't want oxygen in there, but that's better than imploding your tank. And then lastly, sample valves, so you can take samples along the way and see how you're doing in the whole process. So now we're going to go, so far I've talked about why you want to brew using low oxygen methods. We've talked about what is it, what are the prerequisites. We're going to talk really about the how, just the nuts and bolts, step by step. So just before we start, a general tip is on your hoses, you want to purge or pre-fill those hoses. Just leaving air in there is a source of dissolved oxygen. So you can, for example, in your hot liquor tank, you might want to recirculate with boiling water or pre-boiled water. On the mash tun and brew kettle, you can purge the hoses with carbon dioxide or nitrogen. In my own personal setup, which is a small scale personal one, I have a source of carbon dioxide and I just connect it to the hoses and push the air out and leave it, quote, packed with carbon dioxide. So first thing in the process is, monitoring the dissolved oxygen. You need to know how you're doing. How are your methods working? You need to measure this as you go along. There's two ways. The easy way is the dissolved oxygen meter. You can just directly measure dissolved oxygen as you go and see how your process is working. It's the more expensive way. There's a lower cost method, which is using sulfite strips. You can see them here on the left side of the screen. You can use that in conjunction with sodium metabisulfite or potassium metabisulfite in your brewing process. And you can measure the amount of the sulfite that's consumed by oxygen as you go. In this case, you're not really directly measuring dissolved oxygen, but you're measuring the process, and you can see how much oxygen you're how much oxygen you're consuming with the sulfites, and you can see where the dissolved oxygen is coming into your process. And this is this is like a $30 solution versus $250 or $300. We'll talk about adding metabisulfites later. The goal, though, is, if you do use the metabisulfites method, you want to have near zero by the time you get to pitching your yeast, so that you don't have the sulfites left in there to continue to require to be oxidized to get rid of them before you can oxygenate the beer. To take a test, it's pretty simple. You add a little bit of baking soda, a pinch of baking soda to your sample, and use the test strip, and you can directly measure, as you can see this on the left there, how much your level of sulfites. It's a pretty coarse measurement, but it does give you a good feel for what's going on. By the way, every 5 parts per million of sodium metabisulfite drop is a 1 part per million of dissolved oxygen. Okay, so we'll talk about grains and malt conditioning and just grains in general. You want your grains to be fresh, as old stale grains are going to be oxidized grains, so you don't want that. You want good fresh grain. If you can condition your grain first, that's really helpful. You can see the difference here in the malt in the picture. Not conditioned is on the upper left and conditioned on the lower right. You can see the nice husks, the nicer looking grain there. This is possible for, of course, home brewers and small scale nano brewers are probably not using augers and things like that. So this is doable. Bigger breweries, it may not be, and if it's not possible, don't worry about it. Keep your coarse crush. Try and keep that aquaspire intact, and then also probably most importantly, crush immediately before mashing. You have about a 15-minute window between crushing and mashing in before you start having problems with oxidation. Milling. The trick here is mainly go slow, less than 100 RPMs. 3 roller mills or more are going to give you a better crush. So that's the malt milling step here. Okay, the next step is talk about your water. Water is very important. Water contains all kinds of things, metal ions. And so if you can use reverse osmosis or distilled water, you're going to get those metal ions out of the water, because metal ions are a source of oxidation as well. If you can't use, if you don't have this option, that you do have another way to solve this problem, and that's using Brutan B. Brutan B will reduce Fenton type reactions, which is your metal ions are reacting and oxidizing your beer. But you also, a lot of your brewing ingredients have metal ions in them as well. So it's just a good ingredient to add to your brew for low ox brewing, because it'll attack those metal ions and drop them out of the wort and improve your low oxygen beer in your mash, and use this in your mash and in your boil. Excuse me just one moment. Take a drink of water. Okay. The next step, we're going to talk about water some more, getting the oxygen out. There's a couple ways to do that. One way, tried and true, is pre-boiling your mash liquor. Pre-boil that hot liquor tank. This is great. It can get your dissolved oxygen down to 0 pretty much by the time you hit the boil. Your DO is down to 0. This doesn't provide active protection against your dissolved oxygen. It just gets it down to 0. If you let it sit in atmosphere, the air will reoxygenate the water, as we mentioned before, in 1 to 2 parts per million per hour. However, this is kind of the cleanest method. You're not adding anything to the water. You're just pulling the oxygen out. There is another way, and we're going to steal from bakers. You can see down in the lower right, I show a picture of some yeast and some sugar. So yeast and sugar is another way to get the dissolved oxygen out of your water. You basically need some bread yeast, dextrose, and half an hour to an hour, and you're going to eliminate the dissolved oxygen. It takes 1 gram per gallon of sugar and 1 gram per gallon of yeast, and you're going to reduce the DO down to 0 in somewhere between 20 to 60 minutes, depends on your temperature. And it's going to hold it at 0 for about 4 days. So that's really nice. You can pre-treat your hot liquor and let it sit till you're ready to brew for a few days. The advantages of this method are it's providing the active protection for a few days. The yeast scavenging keeps the oxygen out. It's environmentally friendly. You don't have to use energy to pre-boil that water and then cool it back down. And it's less hassle. When you pre-boil your water for the hot liquor tank, you need to cool it back down to strike temp, and takes time and takes a bit of time and trouble to get that done. So this is in some ways a simpler method. Okay, so we're going to talk about metabisulfites now. We talked about pre-boiling and adding your bread yeast. Once you get past, once you heat that water up, of course the yeast is killed. There's no more protection there. And the metabisulfites will give you active protection downstream in the brewing process. You can use either sodium or potassium metabisulfite, and it's going to remove oxygen from your water and wort. It's providing active protection. If you use potassium, you need to keep that down to 10 parts per million, which is for the potassium metabisulfite. That means a maximum of 30 parts per million in your process. If you use the sodium metabisulfite, then you want to start with about 35 parts per million if you're just to pick a number to try. And then as you get experience, you can reduce that down. The goal is when you get to oxygenating your wort, just before that, you want to be at 0. I would say maybe you want to be at 1 or 2 parts per million, so you know that you didn't run out. And if you're at 0, you don't know how much oxidation you caused your beer at that point. So target a very low number, and just as you improve your processes, you can keep reducing that the amount of sodium metabisulfite that you add at the beginning. There's some commercial antioxidants you might check out. AEB makes something called antioxidant SBT or antiox-C. You can go check those out. One thing to note, though, the sodium metabisulfite or potassium metabisulfite, they're not enough to solve the problem of low oxygen brewing. The reason is you can't absorb enough oxygen with the levels that would be good for your beer. In other words, you'd have to put way too much metabisulfite in there to get rid of that oxygen. You'd have other challenges with your beer. So alone, this is not enough, but it is helpful, and it does help cover some of the sins of brewing. So continuing on with water, you want to plan out your treatments. If you're pre-boiling, boil the water for 5 minutes. Use your Herms or your wort chiller. You can cool the water down to 200 pretty quickly. Dose it with your sodium metabisulfite, and then keep chilling down to your strike temp. And then pay attention to the air in your hot liquor tank's headspace as you both cool and as you empty the hot liquor tank. You want to keep that flooded with nitrogen or carbon dioxide. I have a Herms coil in my hot liquor tank, and what I do is if I use the boiling method, I'm at boiling, and I run my pump and recirculate the water through my tangential, so the water in the hot liquor tank is swirling around. And then through the Herms coil, I just run tap water, cold tap water, and I can really quickly drop my temperature. It takes a little bit of finessing to get the timing right so that I don't overshoot my target and have to reheat it. And that's the advantage of the bread yeast method, is you don't have that overshoot challenge. Okay, next slide. All right, we're going to talk about mashing. Some tips on mashing. In your mash tun, before you add grains, purge it. Put some carbon dioxide or nitrogen in there and fill it up with inert gas. Put the grains in the mash tun dry. Don't hydrate them. Just put the grains in. And then when you go to strike in, slowly fill the mash tun from the bottom. You're going to be surprised, if you haven't tried this, that if you fill this slowly and properly, you're going to not have dough balls, and you'll need no stirring or very minimal stirring. Personally, in my brewing process, I don't have to stir at all. If you do stir, which you may have to, be gentle, avoid splashing. Again, splashing causes oxidation. You can use a mash cap on a small brew kettle potentially, or purge that tank with carbon dioxide or nitrogen, the headspace. Also, quick note: when you're putting the grains in, run that carbon dioxide, run that nitrogen from the bottom to keep the air out. When you do the Vorlauf, you want to recirculate below the surface. Some sort of Vorlauf pipe is an example of one on the right. You can adjust that up and down to match the grain bed height, and put it down just below the surface, and you're going to find a really nice even layer of water coming out, or wort coming across the top, and avoiding channeling and also not splashing. And if possible, don't open the mash tun. Leave it closed. Okay, here's something we don't want to do. Don't do this. That wonderful steam and wonderful smell, which I really like, that's all the AAO evaporating, that fresh lingering grain flavor going away. That's the good stuff it's leaving. So don't do that. Just as a quick note, when you start this process, you have that sample valve, you'll taste the wort, and you're going to notice the difference between when you use this processes and when you don't use the processes. Don't do this either. This is creating splashing. So for lautering, it's pretty much the same as the mash tun. Either don't sparge, or if you do sparge, you could use like a Vorlauf tool like we showed before. You could underlet, or if you have the kettle sealed and you have the headspace purged with carbon dioxide, you could then use a sprinkler type system as well. All right, next we're going to talk about boiling. All right, heat stress can accelerate oxidation, so you want to eliminate and avoid heat stress. One quick note is you want to be careful of your thermal heat load. There are some electric systems out there that are strictly on or off on the elements, and when they're on, they create a lot of heat load, which is both going to discolor the wort and accelerate your heat stress. So you need elements, if you have them, that can be controlled temperature up and down, not just strictly off and on. Limit your boil time to 60 to 70 minutes. Before and during the boil, purge that kettle. As you do more and more low ox brewing, you're just going to be very focused on keeping those hoses, kettles, everything purged of air before you use it. Keep the kettle partially open so you can keep that evaporation rate down to 6 to 8%. You want to simmer, not a big, huge, robust boil. Keep the evaporation low. If you're using Pilsner as your base malt, and if your pH in the boil is greater than 5.4, then you can get that evaporation down to 4 to 6% per hour and not worry about off flavors. The low evaporation rates are going to mean lower hop utilization, so you may have to increase your hops to adjust for that. And at the end of the boil, add some lactic acid to get that pH down to below 5.1 if needed. That'll improve your hot break, cold break, and reduce your lag time on the yeast, on the fermentation, which is important to getting keeping the oxygen out of the beer after knockout. And waiting for the slide. Try again. Okay, there we go. When you put your hops in, you might want to think about purging those hops with carbon dioxide or nitrogen. If you have pellet hops, it's going to be a little bit easier. There's fermenter or dry hopping devices out there that probably could be easily used for this as well. You might need a new port on your tank for that, but you might look into a dry hopper to get those hops in there. And then lastly, you definitely want a whirlpool, which again, most commercials or breweries would be doing this, but you want to keep that hot break in the kettle. All right, when we're done boiling, it's really important to get the temperature down to your your fermentation temperature quickly. You want to knock out at your initial lager temperature, which we're going to recommend for the continental beers is going to be 41 to 43 degrees. So, and the reason is, we need to get the fermentation started quickly and get the oxygen out, that the yeast consume the oxygen quickly. So we want to have this temperature down. We don't want to have to wait for that. Some tips and tricks to get your temperature down. One is if you don't have a cold liquor tank, use a fermenter, a spare fermenter, or a spare bright tank to provide that cold liquor instead of a cold liquor tank. If you use typically like 1.35 gallons of cold liquor to 1 gallon of wort, assuming an 8-degree temperature difference between the desired wort temperature and the water, can get you where you need to be, depending, of course, on that heat exchanger. I can't talk about all heat exchangers, but that's what we see typically on the heat exchangers we use. You can also use a 2-stage heat exchanger if the system's sized properly, but that's probably going to mean a lot of horsepower for that 2-stage heat exchanger, and that tends to mean more money and more pretty high energy use during that knockout period. Okay. All right, the next step is we're going to talk about pitching rates. Again, one of the goals here is we need to get fermentation going quickly. So we need to pitch adequately to get a healthy fermentation and a fast start. Target rates are for ales, 1.7 million cells per mil per degree Plato. For lagers, it's 2.5. Liquid yeast is going to be best. It's going to produce more sulfur and fermentation sulfites, and those are what they help protect the beer during your lagering and your serving. Ideally, if you're using the metabisulfites, you're going to have 1 part per million or so when you're pitching your yeast. And I picked that number just because if it's 0, again, you ran out at some point and you've got some sort of dissolved oxygen happening, you can't measure it. Unless you have that DO meter, then you could. Anyway, that will, then when you aerate, make sure you aerate a little longer to consume any sodium metabisulfite or potassium metabisulfite. You want to cool your wort, pitch the yeast, and aerate quickly. But wait, hold on here. How can you add oxygen? You've just spent all this time keeping oxygen out of the wort, and now we're putting it in there. All right, the reason is we're at super cold temperatures now. Now we're down at 41 to 43 degrees. And that low temperature is slowing the oxidation reaction. And it's by orders of magnitude. What would take maybe 1 minute or so, or less than a minute at your mash temperatures, is 8 hours at these temperatures. So we've got time. That 8 hours is time for the yeast to get busy, consume the oxygen, and get the fermentation started. So that's why we want to have our wort cool quickly pitch adequately and get that fermentation started and consume that oxygen. All right, next we're going to talk about the lagering. As I mentioned before, we need to control lagering temperatures. Well, this is not such a good way to do it. This is an old-fashioned lagering room down below some brewery. They're not going to have good temperature control. This is all they do. So you do need like a jacketed tank or some sort of good quality temperature control on your fermenter. Typically, like as I mentioned before, you're going to want to knock out cold, 41 to 43. I picked 42 on the chart. Let it rise over the next couple of days up to your fermentation temperature, which is probably going to be 46 or 48 degrees, and then hold it there for the duration of your fermentation. Now, as you get near the end of fermentation, you're going to want to spoon. What is spooning? Well, that's the traditional German method of carbonation. What it is basically you seal off the fermenter near the end of fermentation, and the naturally produced carbon dioxide, instead of being expelled, is going to build up inside the beer and naturally carbonate the beer. This is your optimum method to maintain the low ox process and maintain the flavor in your beer. So basically what you do is you need to do a fast fermentation, pull a sample of your inoculated wort, let it sit at room temperature so it can ferment quickly. You'll see what your final gravity will be. Now you can know at what temperature you want to close your fermenter when you have 1 degree Plato remaining, because you know what your final gravity should be. And then if you're doing transfers, you also want to do closed transfers. We'll talk more about that in the next slide or two. For spooning, you should all the brewers should be familiar with this. You want to use your carbonation chart to set your spooning pressure and get that desired carbonation level in your beer. And then after the spooning is done, and if you do a transfer, which you may very well do in a commercial brewery, you want to do closed transfers. So one tip is if you have a spare bright tank, or maybe if you're going into a fermenter or unit tank, if you have a spare tank during fermentation, you can capture your carbon dioxide from your fermenter and use that to purge your receiving vessel. So you pump it in, or you hook it up to the bottom inlet outlet of your, for example, bright tank, and let that carbon dioxide from fermentation fill the bright tank and push all the air out. You don't want to do this if you have foam coming out of your pipe, but as long as you have clean carbon dioxide, this is a nice way to save some money and purge that receiving vessel. And you can see here, you want to connect the two CIP pipes together so the carbon dioxide from the receiving vessel flows right into the fermenter, and then the beer flows on the bottom to the bright tank. One note, the hazy IPAs have made a lot of brewers more aware of the need to control oxygen on the cold side. But it's not just the hazy IPAs, all the beers benefit from this, and it's really necessary for the low oxygen brewing to get the lingering fresh grain flavors in the beer. All right. If you're doing kegs, I have an example of a homebrew keg because it's easier to demonstrate, but if you're filling kegs, the method is robust. First of all it takes is a 1 shot glass equals 0.2 parts per million of dissolved oxygen in a 1/6 barrel keg. So it doesn't take much. So you need to get all the air out of that keg. A very reliable way to do that is you fill the keg all the way up with a low oxygen sanitizer, like Iodo-4 SaniClean, something like that. Then you're going to push that entire volume out with carbon dioxide. And then you're ready for that closed transfer, just like we showed before. I can imagine in a commercial brewery, if you do this, making a daisy chain of a bunch of kegs and filling them up with sanitizer one way, and then reverse your connections and push it all back out in one big step. I haven't done it yet, but I can just picture that not being too hard of a process if you set it up. And now we're into the anticipation period. This is the hardest part for me, waiting for that lagering to be all done. So once you're done with the fermentation, the spooning is done and your beer is fermented out, you want to drop down to your lagering temperature, which is going to be 32 degrees per day. Again, we're talking about lagering, not your hazy IPAs, not your ales, but the lagering, the continental lagers, German lagers. You're going to want to drop 1 or 2 degrees per day until you get down to that 32 degrees, and then hold it for your lagering period. The rule of thumb is 1 week per degree Plato of beer. Many brewers do take shortcuts and maybe cut that down to maybe 8 weeks for a Pilsner or Helles, but if you can do the 1 degree per Plato, that's going to give you some nice results. 1 week per degree Plato. I misspoke. Okay, so we're kind of winding up here. I'm going to just cover the major takeaways. And again, we're going to have a handout which will have a lot of these notes for you, a lot of these details. Major takeaways are, for low oxygen brewing, to keep the lingering fresh grain flavor in your beer. Again, you're trying to preserve it. It's there. It's in the malt when you start, as long as you had nice fresh malt. You want to keep it in there. How do we do that? Keep the oxygen out of the system. Purge the hoses, purge the pipes, tanks, kettles. Have sealable kettles. You can't purge and keep the air out very well unless you can close it off. Now, of course, your brew kettle has to be open for venting, but my point is you don't want a wide open kettle. That's going to be a problem. Keep the oxygen out of the mash. Treat that hot liquor tank water. Boil it. Use your yeast conditioning, whatever. Condition the malt if you can. Purge the mash tun before and during use. Bottom fill during the strike. Stop the surface absorption. Again, so you need a sealable tank. Purge those vessels. Keep purging as you use it. Maybe on a smaller system, you can have a mash cap. And I didn't really talk much about this, but a mash cap would be just some physical thing that would sit on top of the mash. Reducing that thermal stress when boiling. Watch your evaporation rate. Keep that low. Don't underpitch, and do ferment cold. Again, fermenting cold for your continental lagers. Let's not worry about that for your hazy IPAs or otherwise. Spoon the beer. The less things you add into the beer, the better. Keeping the transfers closed. And you can do it. Again, it's all about preserving the fresh, lingering grain flavor that already exists in your malt. Getting into low oxygen brewing can be an ongoing process. It can be an improvement program. It can be one step at a time. You might not get there all at once, but you can do it. As you can see, if you really think about these steps, they're not that hard. If you already have a brewery, the modifications to your kettles might be none. They might be just a few ports here or there. It can be done. And again, it's about preserving that flavor, keeping it in there to make those amazing continental style lagers, and to preserve the shelf life, keep the hop flavor fresh longer in your ales, your hazy IPAs. So what I really would love to see, and I'm going to ask, as an aficionado of a quality, continental style lager, Helles beers, pills, they're becoming more popular in the market. I want to see more and more craft style continental lagers. You can do this. It's not that hard. There's not that many changes you have to make. And there's no reason not to start taking those steps. So you can improve the whole industry and improve your own brewery. Lastly, I just want to share some credit here. The Low Oxygen Brewing website, lowoxygenbrewing.com, by Brian Rabe and Derek Scott. That's an amazing resource. There's an April 2016 paper out as well. It's pretty much eclipsed by the lowoxygenbrewing.com. That's what I would recommend instead. And Brian is going to be available to help out with the questions as well. Again, I can't say enough about how much work he's done. And if you get on that Low Oxygen Brewing website, he's shared his time freely, his efforts freely. He shares his research. He's doing practical research, university quality in my mind, data collection, but at a really practical level. So it's just been an amazing resource for this process of brewing. And I've been really enjoyed working with Brian and having fun doing this myself. And with that, we are ready for some questions. And I'm going to pull up my questions here. So we have 3 questions. And I'm going to turn my camera back on. Okay, Brian, you want to jump in? You talk for once.
Thank you. Thank you very much. Yeah, I can certainly answer the questions. So the first question I see is, can metabisulfites be added to the mash or pre-treat water only? You can always add the metabisulfites at any point. The reason why we say to add to the liquor or the strike water is because then you'll homogenize those antioxidants. And as you're doughing in, you'll have much greater full coverage protection than if you were just to sprinkle some powder in the mash. So there, even if you do purge the mash, you will still have some grain inherent in the husks and all the little nooks and crannies there. So we definitely recommend you just put it in the water, allow that antioxidant to disperse, and then you'll have much greater protection. Conditioning of the malt. Conditioning of the malt is kind of a poor man's way to get a really nice professional brewery quality crush. And what you do is you use 1 to 2% of water by weight of your grain. And you would just get a spray bottle and you would sprinkle that on and let that rest about 10-15 minutes. And that water will absorb in those husks, and those husks will become nice and pliable. And once they're nice and pliable, when you run them through the same, you don't have to adjust your rollers per se. If you ran in that slide, the conditioned and non-conditioned malt was ran through the same gap on the roller, on the mill. And you can see that when that little bit of water hits that husk and is allowed to rehydrate that, as it were, you get a much finer, or a much more beautiful husk. And the husk is going to help you with tannins, potential tannins, and other husk matter that you don't want in the beer. And it will help you as a filter bed. And also what we touched on was the archospire in the malt. And once that archospire in the malt is crushed, that's when the lipo-oxygenase and those kind of things touch the oxygen and can start staling. So we want to keep the kernel as intact as possible with the husk pliable and intact as possible to allow us for that. So the next question, is there a way to make a batch of low DO water for brewing? Yeah, you can use any one of a bunch of different methods. One is the pre-boil and cool. The second is the yeast method. And the third would be an oxygen stripping column, which a lot of the professional large breweries do have. Think of it as a distillation column that's packed with like a stainless steel scrubby, and nitrogen or a stripping gas would enter the bottom. And as the liquor water comes through the top, it gets spread out in drips, and then that gas strips those drips of oxygen. Yeah, so a lot of experience with antioxidant SBT. Antioxidant SBT is a commercial antioxidant. We tested it in the brewery here many years ago, right when it first came out. It's a blend of potassium metabisulfite, ascorbic acid, and some gallotannins. So it's basically an off-the-shelf pre-made blend that encompasses kind of what we talk about as well, as far as the metabisulfite and the Brutan B. The Brutan B itself would be a gallotannin. And so this off-the-shelf mixture does account for that. And ascorbic acid, as you saw from the malt, the AAO, ascorbic acid, vitamin C is also a natural antioxidant, and many other things. And you can also add vitamin C or ascorbic acid as an antioxidant for mashing. The only caveat with that is if you add ascorbic acid without the presence of sulfur dioxide, you can actually get what's called a superoxidative reaction. So whenever you see ascorbic acid, it'll usually be listed with some other form of antioxidant that could create sulfur dioxide, in this case, metabisulfite. Is there guidelines for adjusting water profile when using SMB? So yeah, the breakdown of sodium metabisulfite is going to be sodium and sulfate. So though that will react, once it's reacted with oxygen, it will break down to sodium and sulfite. And depending on your dose, if you're using a dose that is, say, 30 particles per million or under, that is going to be pretty negligible. It's going to be minuscule, maybe 5 or so parts per million of sodium and a little bit more sulfate. So is there a way to filter without incorporating more DO? Yeah, I mean, filtering is so hard. Moving beer post active yeast is so hard for DO pickup. You know, your biggest DO pickups are always going to be your transfer to your bright and your transfer to filtering and then to packaging. The best thing you can do is just make sure all your lines are purged, whether with deaerated water to wet your pads or to use some kind of gas. Make sure you discard, you know, whatever's going to be caught up in that filter housing, you know, whether it be a half barrel or a barrel of filtered beer. So you can, you know, all that first stuff being pushed through the filter will be oxidated because there will be oxygen hanging out on the plates and that kind of stuff. So it's kind of really filtering, and that is really difficult, and you want to, it's hard for DO pickup. Is there a difference between Lodo and non-Lodo beer? Yeah, so definitely right off the top. If you were to take 2 beers, one of them being low oxygen, one of them being not, you will notice a lot of things right away. One is the aroma coming out of the glass. You'll notice a definite difference in aroma. The low oxygen beer is going to be much richer. It's going to be much more doughy, bready, grainy. If there is hops present, those hops are going to be much more vibrant as well. And the reason being is when beer is oxidated on the hot side, you're not just oxidating malt compounds. Well, you are. But when you get to the cold side, if you have exhausted all those natural malt antioxidants, the first thing that's going to oxidate on the cold side are going to be your hop polyphenols and antioxidants. And so those are going to be the first thing to go. And when you're really stringent and strict on the hot side, limiting DO, you're going to notice that your hops are going to pop and be way more brighter. And so those kind of things are going to jump out at you right away in the glass before you even take a sip. And when you do take a sip, I don't know how many people in the audience have had, fresh, I just go back to like German beer, whether it be any of the Munich breweries or the continental breweries. If you've had any of that fresh beer from the keg at the source, it's kind of a life-altering experience. There's qualities in the beer that you just can't get over here. And it's not the same bottled and shipped over here either. So a lot of those same qualities are going to be present. Upon flavor or upon drinking, the flavor is going to be starkly different. It's going to be rich and sweet, but not cloying. Drinkability is going to be through the roof. It's going to be smooth. And so you'll notice it's really, really easy to pick the odd man out.
I think that's it for our questions. Oh, here's another one.
If one is not doing any of these methods, so your best bang for the buck, and really where it starts is your strike water. You have to deoxygenate your strike water, because if you do not, then it's not going to work. And so, because that's your biggest source of oxygen, and the minute you dough in less than a minute, all of your malt antioxidants are going to be gone. So you have to deoxygenate your liquor. What I would do if I had to pick 3, I would say deoxygenate your strike liquor, dose it with enough antioxidants to cover you, and then on the cold side, spund. And that will give you your best bang for the buck. What nitrogen bottle seems to be so you're going to go, it depends. You can use CO2 as well. Like for myself, I have large cylinders of both in the brewery. I don't know what size those are. Are they Ks? I'd have to look it up. They're the tall ones. They stand about 5-6 feet tall, and they're probably 8 to 10 inches in diameter.
It's like called a 220 or a 240.
Yeah, something like that. So I have both of those in the brewery because I use, CO2 to move things around the brewery, and I use the CO2 and nitrogen, whatever. But yeah, you can get away for quite some time on like a 20-pound CO2 cylinder. You could probably get, depending on how much purging and depending on what you're doing, you could probably get a solid, 50 brews out of it. I have tried. So I don't know if they can see these questions too, but the question was using the yeast and sugar, a pH drop. So yeah, there's definitely a possibility if you allow that yeast and sugar water to sit around long enough where it will drop the pH, much like brewer's yeast will drop the wort pH before it starts fermenting. You can always add a little bit of alkalinity to the water to add that buffering capacity. Oh, I saw a blip of one, and it went away.
It went, yeah. Something about Loto, I didn't see it.
I think it said, I think the blip I saw said something about, are any commercial breweries using this? And the answer is yes. Sierra Nevada is one of the largest here in this. Well, Budweiser is the largest in the States. Sierra Nevada is probably a close second, as far as they're very conscious about oxygen and dissolved oxygen. They mill under nitrogen. They are very conscious of that. I know a lot of the new breweries out east, as far as like Hill Farmstead, the Alchemist, all those guys are very conscious about oxidation on the hot side as well. A lot of them also have brand new state-of-the-art German brew houses, and there isn't a German brew house that comes out of Germany nowadays that doesn't take into account HSA. How to deal with oxygen pickup in beers that are free? That's tough. I don't think you can. You can do the best you can, but at the end of the day, all of those ice box and that kind of stuff have a oxidation sherry character anyways. So that's actually part of the style. On our scale, there's not much you can really do about it, except when you're pulling off that liquid, try and get some re-fermentation in the bottle or in the serving keg to try and scrub that a little bit. No, I wouldn't say to send your copper chiller to the scrapyard, but definitely include some kind of gallotannin, brutan B into that to chelate, however you want to say it, those copper ions, and leave them in the trube.
I think we're all done with the questions. Oh, here's another one.
Can you get away with no mash cap by purging your mash tun and leaving your lid on? Yeah, probably. Definitely purge the headspace nice and good. You are going to be using some form of antioxidants. So there will be, since it's not gasketed, there will be some laws of partial pressure happening, which means there will be some gas exchange from oxygen to the CO2 or whatever you're purging with. But those active scavengers, that's what they're there for. Sure. Yeah, a lot of people, as far as a lot of people are going to a condenser type setup, and I know professional brewers have been using condenser type setups for quite some time. The nice thing about the condenser setups is they actually do allow you to really turn down your boil power and get you much less thermal stress naturally by the way they work. Shear stress is definitely a thing to be conscious of. On the homebrew scale, it's actually much less than the larger scale. That's one of the things we have as an advantage to us. The larger scale mash rakes and stuff like that can really do some damage on not only wort but hops and everything. You can definitely go, if you are concerned about it, you can definitely go with a DC pump and then run some PWM type setup on it so you can actually control impeller speeds. Otherwise, the normal mag drive pumps that we use, I mean, it's not great, but that's what we have. And if you just, the problem with throttling down your flow on the mag drive pumps is the impeller still spins at the same speed. But since we're dealing with less volume, we have actually less shear forces as well.
Okay. Well, thank you, Brian. Great job on answering the questions. I just want to ask, I think with your system, you've got pretty much all of the things we've talked about here implemented. And what kind of dissolved oxygen uptake are you seeing in your system?
So with the way I run my system and whatnot, you know, obviously we design the system 100% around low oxygen brewing. So all the vessels are sealed, all the vessels are purged. And I actually have in-process DO meters. I have about 8 in-process DO meters in my system, from hot liquor tank all the way through all the different processes. And right now with my purging and my methods, I have 0.00 DO pickup. That's as kind of as low as my meters can read. I know there's some there, but it's very minuscule. It's very on par with what the large, you know, commercial German continental breweries see in the mash and boil hot side.
So you're not using SMB or KMB, right?
No, I don't have to. I definitely don't. Normally, I do not. I brew according to the Reinheitsgebot, so I don't use any of. Generally, I don't use any of the scavengers, even though I think it could be argued you could, because upon oxidation, they just become sodium and sulfate. So
yeah.
But it's definitely not needed. No.
Great. Well, I know I've had great success with it. And oh, here's another question that popped up.
Can you do a partial spun and finish with forced carb? No. The problem with, I mean, you can do it, but you will definitely see those fresh flavors start dropping. They'll probably start at about a week. If you truly do a full spun, those flavors will probably be there for 9+ months if the beer is kept cold. And even if it's kind of abused warm, it'll still stick around for much longer than it ever would if it was forced carb. But the minute you start forced carbing, there's impurities in bottled CO2, and one of the largest impurities in bottled CO2 is the oxygen content. And depending on how many nines you have after your 99.9999, however many nines you go, that has less oxygen impurity. But the problem with the normal standard, beverage grade is that it has 20 to 50 particles per million of oxygen impurity in the tank. And so you're directly injecting that into your beer. So you can't force carb, because you'll be above the packaging limit, and that's when you'll start to see flavor degradation.
So that begs the question: if you do the full spoon to get your full carbonation that way, but then put the keg on a tank of CO2 in order to serve it, you're going to be introducing oxygen at that point as well, right? So you have to
absolutely. But the difference being you use about half as much CO2 to dispense than you do to carbonate. And when you're carbonating, you're directly injecting that oxygen into the beer. Whereas it's just a little bit different if you're just using it to push. But that's inevitably, you're going to have to do something unless you do some kind of a cask or gravity drain. But still, you're going to need some gas to make it up. So where everybody's handcuffed, and when I say everybody, I mean every brewer in the world is handcuffed, is using CO2 to dispense. The best way to get around that, I know myself and some others, we use some real high quality lab grade CO2 here with less than 10 ppm of oxygen for the impurity. And so we can really extend that freshness.
Is that readily available at your local welding supply, or is that something trickier to get a hold of?
Yeah, so it all depends, because here I'm in Minnesota in the Midwest, and we have a large number of ethanol plants. And one of the ethanol byproducts for their plants is CO2, because they recover tons of CO2 for the ethanol manufacturing. And so we get the benefit of having that, which is basically fermentation gases, and that's what we preach. We get the benefit of having that bottled. And so it's really plentiful around us, around me in Minnesota, especially in my location in Minnesota. So a lot of the beverage grade, I can ask for a COA or a certificate of authenticity, and that will tell me my exact impurity and beverage grade. And much of it is coming sub 10 ppm, and I'm still only paying beverage grade for it. So really what you just need to do is you just need to ask around to your CO2 providers, ask for some certificates so you can actually see what you have. Great.
Well, everyone, thank you very much for attending. Brian, thank you so much for not only being here today, but just for all the work you've done. It's just been a real fun process for me personally. I've really enjoyed making better beer, and it's a style that I really appreciate. And it's just been a lot of fun to do. And everybody else, if there is a handout which is maybe available. If not, it will be. You might check your screen. There should be a handout available. You can download. If you can't get it, you can follow up with us later and we can get it to you. It's going to have like a lot of those details that I mentioned and kind of talked about maybe pretty quickly. LowOxygenBrewing.com has a ton of information out there. Probably everything I said and a lot more is going to be out there, and more details of how do you actually do the malt conditioning. I didn't have time to cover everything. But just great amount of information there. And thank you all for joining us, and enjoy the rest of your virtual Brewers conference. Thanks again, Brian.
Thank you very much, John. And thanks.